Welcome to Science Conversations. I'm Kaysie Vokurka. Is there a problem with radiometric dating? Joining me to discuss part one of this topic is Dr. John Ashton. Welcome to the program, Dr. John.
Hello, Kaysie.
Dr. John Ashton has written a book entitled Evolution Impossible: 12 Reasons Why Evolution Cannot Explain the Origin of Life on Earth. And we'll be referring to his book as part of this program. So that is a big question. Is there a problem with radiometric dating? What would you say?
Well, I think one of the fundamental principles of evolution is that the evolutionary process took place over hundreds of millions of years. The theory requires a large amount of time. And the main evidence that people put up for this large amount of time is the radiometric dating results. So if we look up to sort of, say, the 1800s, most university and many scholars and geologists accepted the biblical worldview of that the ages of the Earth were relatively young, in the order of 6,000 years. There was a global flood about 4,500 years ago, this sort of time frame. Once the theory of evolution was constructed, and prior to that, the development of ideas that maybe the Earth was very old, and these ages were initially based on looking at the rates at which sediments and strata were laid down, and the early estimates gave values that when they looked at the thickness of strata, they calculated, millions, tens of millions, even hundreds of millions of years. And so this was the foundation of the basis of these long ages. And once radiometric dating methods were developed in the early 1900s and then later refined, particularly from the 1950s onwards, then these data has been cemented in. And essentially people are very reluctant to move away from these dates. One of the important things is, though, that we have prima facie evidence that these dates are wrong. And this is very hard for people to accept and often, even consider. And it's one of the things that if you begin challenging these radiometric dates, you're automatically written off. And one of the reasons I think is that these dates are essential to underpin the foundation that we've had long ages and hence time for evolution to occur. And once you start threatening that, the other alternative, of course, is the creation model. And people don't want to go there, it seems. So there's really a political view or a worldview that wants to hold on to the fact that the Earth must be very old and very different to the biblical timeline. And this is very important to understand, that it's really a battle of worldviews, and these views are really based on faith positions. But when we look at the evidence, the growing evidence is actually supporting the biblical worldview. Now, one of the things that comes out of this is that, why isn't there science debate over these, the conflicting evidence that we'll talk about in a moment? And it's very important that it seems that these areas are closed down. Once you go there, if you try to publish research papers in this area, you're closed down. There's interesting, a couple of documentaries have been, a documentary was made by Ben Steiner. I just refer to the name now. It was called The Slaughter of Expelled, the movie. And that was a documentary where Ben Steiner interviewed scientists who'd had their research grants cut, their publications withdrawn and so forth, because they were putting evidence up that countered the evidence for evolution. One important book that I'd like to refer to is a book by Dr. Jerry Bergman, who has a number of doctorates, different areas, and a very prolific writer, academic, who's a very prolific writer, and he put out a book, Slaughter of the Dissidents, The Shocking Truth About Killing the Careers of Darwin Doubters. And that book was published back in 2008. Now, back then, he documented these cases of where people said, hang on, we've got major problems with the theory of evolution. We've got major problems with the scientific evidence supposedly supporting this. And he documents how these scientists then were closed off. Their careers were either shut down or their work was not, published in the scientific journals. Now,
Can I just say that really is an interesting thing to observe, because science of itself is something which everyone should have an open mind about what the evidence is speaking about to be a true scientist. So for some scientists to be shutting down other scientists because they're putting forward evidence, like that kind of betrays another priority than purely knowing what the science is saying. They must want to hold on to, as you said before, about a worldview. They want to hold on to that over what the science is saying, rather than seeing the truth of what the science is actually saying.
Yes, exactly. And this is a very important area that we need to bring up, because so many people think that, evolution has been proven. Evolution hasn't been proven. And one of the factors that, for example, that counters this view of long ages is erosion rates.
Okay.
And this is a very important area, because this is something where we can measure data now, today. We've got very sophisticated measurements now of measuring erosion rates, but it's been known for quite some time. Matter of fact, it's not new for geologists. Since the 1950s, for example, a number of geologists have pointed out that based on estimated erosion rates, the North American continent, for example, which has an average height about 620 metres, could erode away in just 10 million years. And yet on the basis of radiometric dating, it supposedly formed 2,500 million years ago, or 2.5 billion years ago. And here we have something, according to radiometric dating, formed 2.5 billion years ago. And yet when we measure erosion rates, it would erode away in less than 10 million years. And this isn't, fringy creationist data or anything like that. I'm not saying there that creationists are fringy, but a lot of people view them as such. This is data that it's published in, leading, journals, such as, for example, some of the ones would be the Journal of Geophysical Research, and that was a paper published, Rates of Regional Denudation in the United States, Journal of Geophysical Research. Another one was the major geology textbook, Evolution of the Earth, published by McGraw-Hill Book Co. and so forth in 1988. So this is data that's in the standard geology textbooks. It's in the standard, geology research journals, and there's a lot of data on this, on erosion rates. People have also measured the erosion rates on different mountains, for example, and different areas around the world. And this rapid erosion that would take place in only millions of years of the continent is supported with data all over the world. We've got, for example, erosion rates from and when you look at them, if you look at the Weho River, then it lowers the surrounding area by over a metre a year per 1,000 years.
Wow,
so yeah. And so once you get into millions of years, if it's eroding the area a metre per 1,000 years, a million years, that's 1,000 metres. That's going to erode it away.
Gone.
yeah. And the Huang Ho metre is lowering the local topography by nearly a metre, 900 millimetres per 1,000 years. And 900 millimetres per 1,000 years, we can see, it's only a small amount. But once you start claiming that something is millions of years old, you're multiplying those factors up by 1,000, and
Yeah.
once you get 100 million years old, 100,000 times those rates. So those represents massive erosion rates. Even the Amazon, 71 millimetres per year. The Yangtze, 170 millimetres, sorry, not per year, per 1,000 years. Once we get to very, very high ranges, we also have similar years. So in some areas of Papua New Guinea, for example, you have erosion rates of close to 20 metres per 1,000 years.
Wow.
So you got,
that's
once you go over 1 million years, yeah.
And I guess those areas would have higher rainfall, is that right?
Yes, that's right, in the mountainous areas of Papua New Guinea. Even around Mount Rainier in Washington, it's about 8 metres per 1,000 years. So we have these very, very high erosion rates. Even if we look at the Grand Canyon, now that's about 1.4 kilometres high, I think, about a mile high. And we've got, fossil-bearing strata going back 500 million years, with the oldest rocks claimed to be about 3 billion years old. However, if we look at the current erosion rates in that area, that whole canyon should have completely eroded away in less than 20 million years.
20 million.
Less than 20 million years.
That's a huge gap.
Yep. Because the Colorado River is eroding the local area about 4 inches or 100 millimetres per 1,000 years. So you just do the maths.
Yeah.
100 millimetres per 1,000 years. How long to erode 1.6 kilometres? And it's less than 20 million years.
So what I find I'm interested in, like earlier you were explaining about the history of how scientists used to think that, like in the 1800s, they had the creationist biblical worldview. Then they looked at sedimentation rates and erosion rates. That put a few more million years. They
just looked at sedimentation
rates
sedimentation. At certain river mouths.
Okay, yeah.
Yes, okay.
But then from there they jumped to the radiometric dating.
Well, radiometric dating is really the first radiometric dating I think was around 1910, something like that, was first proposed that they could use radiometric decay because they were only just beginning to do the measurements on radiometric dating and, of course, on the half-life of radioisotopes. So to understand this and also to improve the accuracy. So the accuracy in terms of understanding nuclear reactions and these sort of data is really post the atomic bomb because a massive amount of research was done in developing the atomic bomb, measuring isotope rates and this sort of thing. So that's why after the war, 1948 onwards, they began to standardise and have standard rates, much more accurate measurements of the decay rates of the different radiometric isotopes.
So then has it been in more recent years that they've also done these studies on the erosion rates and sedimentation rates in the different areas? Well,
no, the erosion, they had the earlier dates. So the fossil record was based essentially on these estimates of sedimentary rates that were done. And that's where they got the large numbers of hundreds of millions of years from. And it just so happened, and it's very interesting, that the radiometric dating method seemed to confirm the estimates of the original ages that had been based on sedimentary rates. The initial ones were work done, I think, in the Appalachian Mountains, and they did a number of measurements, and they just all happened to fit. It was an amazing coincidence. But then after that, as I said, these scientists from the 1950s on, geographers and that, began pointing out, well, hang on, okay, you seem to have a good fit there, and that one set of data that fitted really well really worked. But then they point out, hang on, we got this massive amount of data from elsewhere that's accumulated since the 1950s up to the present time that shows, hang on, these long ages can't be right. The erosion rates are so high, the continents would have eroded away.
Wow. Interesting stuff. We're going to talk more about this in our next part of this session. So hold the thoughts, we'll keep it going. Next time we're going to continue to examine the question, is there a problem with radiometric dating? Be sure to join us.